Okay, so you're here because you want to be on the bleeding edge of AI research, right?
Yeah.
Well, look no further, because today we're diving into affordable AI assistance with knowledge graph of thoughts.
Catchy title.
It is, and it really gets to the heart of what this paper is all about.
Yeah.
Basically, they introduced this thing called KGOT, which is a new architecture where AI assistants can actually build knowledge graphs as they're working on a problem.
Interesting.
Yeah, so think about it, like instead of just processing text like a huge blob of text, it's creating this structured representation of the information.
Ah.
And the crazy thing is that they show that with KGOT, you can actually get smaller, less expensive AI models
Okay.
to perform just as well as those giant models like GPT-4o.
Wow.
Yeah, and they tested this on the GIA Benchmark, which is notoriously difficult.
Right.
And not only did they get comparable performance, but they also significantly reduced the computational cost.
So it's kind of a win-win.
Exactly. It's like a huge leap forward in terms of efficiency and accessibility.
That's really impressive.
Yeah, so we're going to break down all the juicy details of this paper for you today.
I'm excited. Sounds like this KGOT thing could be a game changer.
It really could. So let's dig in.
Right.
So one of the things that really stood out to me about this paper is how it addresses a really fundamental problem in AI right now.
Okay, what's that?
Well, we've seen all this incredible progress with large language models and AI agents.
Yeah, for sure.
But the truth is, they can be really expensive to train and run.
That's true, especially those massive models.
Right, and the GAIA benchmark that they use in this paper, it really highlights this problem.
How so?
The GAIA throws all these crazy challenges at these AI systems.
Like what?
Things like navigating the web, executing code, understanding images, answering complex questions.
Oh, wow. That's a lot.
It is. And while the biggest models can sometimes kind of brute force their way through the tasks, the costs can be just astronomical.
Yeah, I've heard that just validating on GAIA with GPT-4o can cost like $200.
Yeah, exactly. It's insane. And that's just for validation, not even for training.
So what do people do if they can't afford to use those massive models?
Well, they often have to settle for smaller, more affordable models like GPT-4o Mini.
Right.
But the problem is that those smaller models often can't complete as many tasks.
So it's a trade-off between cost and performance.
Exactly. And that's where KGOT comes in.
Okay, so tell me more about how it works.
Well, the fundamental idea is that instead of treating the task as like this big chunk of text, KGOT actually builds a knowledge graph as it's working on the problem.
A knowledge graph, so like a visual representation of the information.
Exactly. It's basically a way of organizing all the important entities and the relationships between them.
Huh. Okay, I'm kind of picturing like a mind map or something.
Yeah, sort of, but it's more structured and it's constantly evolving as the AI learns more about the task.
Okay, that's pretty cool. Can you give me an example?
Yeah, so in the paper, they give this example of a level 3 GAIA task, and it involves finding a number that's mentioned after the word dinosaurs in a YouTube VR video that's narrated by the voice actor of Gollum from Lord of the Rings.
Wow, that's specific.
I know, right? It's like super complex.
Yeah.
And for a regular LLM, it would have to keep track of all those details like Gollum, voice actor, YouTube video, dinosaurs number, all within its context window.
Right.
But KGOT tackles this by building a knowledge graph step by step.
Okay.
So it might start with a node for Gollum from Lord of the Rings.
Okay.
And then as it reasons through the problem, it might realize, oh, Gollum is played by Andy Serkis.
Right.
So then it adds a new node for Andy Serkis and connects it to Gollum with a relationship like interpreted by...
So it's kind of like building a family tree, but for information.
Yeah, exactly. And as the AI keeps thinking about the problem, it adds more nodes, more edges, and more attributes to the graph.
And this helps it to understand the task better.
Precisely. It's like having this external brain that's constantly being updated and refined.
That's really interesting. So how does this knowledge graph actually help the AI to solve the task?
That's a great question. So the knowledge graph becomes this central hub that the AI can use to interact with external tools and retrieve additional information.
Okay, so it's not just a static representation of the data.
Right. It's actively using the graph to guide its exploration and problem solving.
Cool. So what kind of tools can it use?
Well, they've integrated a whole bunch of different tools like math solvers for doing calculations,
Okay.
web crawlers to search the internet, Python script executors for more complex logic,
Wow.
even specialized tools like YouTube transcribers to get the text from videos.
That's impressive. So it's like it has all these different superpowers at its disposal.
Exactly. And it can choose which tools to use based on the current state of the knowledge graph.
So going back to the Gollum example, how would KGOT use these tools in that scenario?
Right, so let's say the knowledge graph now knows that Gollum is played by Andy Serkis.
Okay.
The AI might then think, okay, I need to find YouTube videos narrated by Andy Serkis. And to do that, it would use a web crawler to search for relevant videos.
That makes sense.
And once it finds some potential videos, it can use the YouTube transcriber to get the text from those videos.
Okay.
And then it can analyze that text to look for mentions of dinosaurs and the number that follows it.
Right.
And all of this new information, the video titles, the publication, dates, the relevant snippets from the transcripts.
Yeah.
All of that gets added to the knowledge graph.
So the graph is constantly growing and becoming more detailed.
Exactly. It's like a living, breathing representation of the AI's investigation.
I like that analogy, a living, breathing representation.
So once the graph has enough information, the system needs to figure out how to extract the answer to the original question.
Right, because it's not just about collecting data, it's about using that data to solve the problem.
Exactly. And they actually describe a few different methods for doing this.
Oh, cool. Tell me about them.
One approach is to use graph query languages like Cypher or SparkCool.
Okay, I've heard of those.
Yeah, so the AI can generate a specific query to retrieve a particular subgraph or a set of relationships that directly answer the question.
So it's like asking a very precise question of the knowledge graph.
Exactly, and this works really well for tasks that involve finding specific patterns or connections within the graph.
Like finding all the videos narrated by Andy Serkis that mention dinosaurs.
Yeah, exactly. But what if the question is more complex and requires more than just simple pattern matching?
Good point.
Well, in those cases, they can use general-purpose programming languages like Python
Okay.
to write scripts that can traverse the graph and extract the necessary information.
So they're basically giving the AI the ability to write code.
Kind of, yeah. It's pretty wild, and this approach gives them a lot more flexibility for tasks that involve following more intricate pathways through the graph or doing more complex calculations.
Interesting. So it's like they have these two different tools for extracting answers, one that's very precise and one that's more flexible.
Right, and they found that they actually complement each other really well.
Okay, that makes sense. Is there another way to get answers from the graph?
Yeah, they actually have a third method called direct retrieval.
Direct retrieval? What's that?
So basically, once the knowledge graph is sufficiently rich, they can just take the whole thing and paste it into the LLM's context window.
The whole graph.
Yep, and then they ask the LLM to infer the answer based on all that information.
Oh, wow. That's interesting. So it's like bypassing the need for a specific query or script?
Exactly. It's more like a brute force approach, but it can be surprisingly effective in some cases.
Especially if the answer is kind of spread out across the graph.
Right. So they have these three different methods for extracting answers.
Yeah.
And each one has its own strengths and weaknesses.
It's all about choosing the right tool for the job.
Exactly. And they actually found that by combining the results from different methods, they could get even better performance.
Oh, cool. Like a hybrid approach.
Yep. So they did these fusion experiments where they used multiple backends and multiple solving methods, and the results were really impressive.
So it's like the best of both worlds.
Exactly. Now let's talk about the system architecture itself.
Okay, let's get into the nuts and bolts.
So they have this really modular design with three main components: the graph store module, the controller, and the integrated tools module.
Okay, let's start with the graph store module. What is that all about?
So that's where the knowledge graph actually lives.
Okay, makes sense.
It's responsible for storing and retrieving all that structured data.
So what do they use for the backend?
They actually use Neo4j, which is a graph database.
Neo4j, I've heard of that.
Yeah, it's really good for handling graph queries.
And they use Cypher for the query language, right?
Yep, they chose Cypher over SparRQL because they found that LLMs are actually better at generating correct Cypher queries.
Interesting little detail.
Yeah, but they also provide a way to access the graph using Python.
Okay.
So for that, they use the Network X library, which is more lightweight and allows you to manipulate the graph data directly.
So you have the choice of using Cypher or Python depending on your needs?
Exactly. And the cool thing is that the architecture is extensible. So you could potentially plug in other graph databases or programming language interfaces if you wanted to.
That's nice. It gives you some flexibility.
Now let's move on to the controller.
All right. The brain of the operation.
Yeah, basically the controller is responsible for orchestrating the entire process.
Okay.
So when a user asks a question, the controller figures out how to answer it using the knowledge graph and the available tools.
So it's like the project manager.
Yeah, exactly. It decides which tools to use. It integrates the results back into the graph, and it keeps everything running smoothly.
Sounds like a tough job.
It is. And to make it even more interesting, they actually use a dual LLM architecture for the controller.
A dual LLM architecture. What does that mean?
So they have two different LLMs working together, one called the LLM Graph Executor and one called the LLM Tool Executor.
Okay, and what do they each do?
Well, the LLM Graph Executor is like the strategist. It focuses on the knowledge graph itself, so it figures out what information is needed, it formulates the queries to the graph store, it parses the results, and it puts everything together to generate the final answer.
So it's like the mastermind behind the scenes.
Exactly. And then the LLM Tool Executor is more like the field operative.
Okay.
It takes the plan from the Graph Executor and executes it by using the external tools.
So it's the one that's actually interacting with the outside world.
Right. It's running the web crawlers, the Python scripts, the YouTube transcribers, all that stuff.
And then it sends the results back to the Graph Executor.
Yep. And that way they can divide and conquer the problem.
That's a clever design.
Now let's talk about the integrated tools module.
All right. What kind of tools are we talking about here?
So they have a whole suite of specialized tools organized in a sort of hierarchy.
Okay.
At the base level, you have the Python code tool, which lets them run Python scripts.
Okay.
Then there's the LLM tool, which is basically another language model that they can use for reasoning and knowledge retrieval.
Interesting.
For visual tasks, they have the image tool.
Okay.
And for web browsing, they have the Surfer agent, which is inspired by the Hugging Face Transformers library.
Cool.
It has a Wikipedia tool navigation controls, and it uses an external search API like SirPoppy.
So it can basically surf the web like a human.
Kind of, yeah.
Yeah.
And then they have the extract zip tool for handling compressed files.
Okay.
And the text inspector tool, which can extract text from all sorts of different formats like MP3s, YouTube transcripts, and documents.
Wow, that's versatile.
Yeah, it can handle pretty much anything you throw at it.
So they've really thought about all the different kinds of data sources that an AI assistant might need to access.
Exactly. And the modular design of this tool module makes it really easy to add new tools as needed.
That's important because the field is constantly evolving.
Now, they also talk about some of the optimizations they made for performance and scalability.
Okay, like what?
Well, for one thing, they use asynchronous execution.
Okay,
So they can run multiple LLM and tool invocations in parallel.
that makes sense.
They also parallelize the graph operations within Neo4j.
Okay.
And they even explore using MPI for distributed computing.
Wow, so they're really squeezing every bit of performance out of the system.
Exactly. They've put a lot of effort into making it fast and efficient.
Now, what about error handling? That's always a big challenge with AI systems.
Yeah, for sure. So they actually have a multi-layered approach to error handling.
Okay, tell me more.
For syntax errors in code or queries, they use Langchain's JSON parsing capabilities to detect and fix those errors.
Okay.
And if the errors can't be fixed, they have retry mechanisms and logging in place.
So they're not just giving up at the first sign of trouble.
Right, and for API or system-level errors, they use exponential backoff.
Exponential backoff, what's that?
So basically, if an API call fails, they wait a little bit and then try again.
Okay.
And if it fails again, they wait a bit longer and try again.
So it's like they're being polite and not spamming the API.
Exactly. It's a common technique for dealing with unreliable service.
Makes sense. And they also mentioned something about containerization for security.
Yes, so the Python Executor tool, which runs the LLM-generated code,
Yeah.
that's actually containerized using Docker and Saris.
Okay, I know Docker. What's the rest?
Saris is similar to Docker, but it's designed for high-performance computing environments.
Oh.
So typically, containerization creates this isolated and secure environment for running the code.
So it prevents any malicious code from escaping and wreaking havoc.
Exactly. It's all about keeping things safe and contained.
That's good because security is always a concern when you're executing code that's been generated by an AI.
Now, speaking of code generation, they use Langchain extensively throughout the system.
Langchain? Yeah, I've heard of that. What does it do exactly?
It's a framework that simplifies the development and orchestration of LLM-driven applications.
Okay.
So it helps with things like prompt engineering tool integration and managing the flow of information between different language models.
So it's like a toolbox for building LLM applications.
Yeah, exactly. It makes their lives a lot easier.
So they've put a lot of thought into the architecture, the tools, the optimizations, the error handling.
They really have, it's a very well-engineered system.
But the big question is, does it actually work?
Right, let's get to the results.
Drum roll, please.
So they evaluated KGOT on the GAIA benchmark, which, as we mentioned, is very challenging.
Yeah, it's designed to push these AI systems to their limits.
And they compared KGOT against several baselines, including Hugging Face agents, with both GPT-4o Mini and the full GPT-4o.
Okay.
They also tested zero-shot versions of these models.
And what did they find?
Well, the results are really impressive.
Okay, tell me the good news.
Across all the different KGOT configurations they tested, They consistently solved more tasks than Hugging Face agents.
Even with the smaller GPT-4o mini model.
Yep. And even more importantly, they did it with significantly lower computational costs.
How much lower?
They reported cost reductions of between 42% and 62% compared to Hugging Face agents.
Wow, that's a huge difference.
It is, and it really highlights the efficiency of their approach.
Yeah. Now, what about the different methods for extracting information from the knowledge graph? How did those compare?
So they tested using graph queries, direct retrieval, and they also did these fusion experiments where they combined the results from multiple methods.
Okay.
And they found that the fusion runs actually performed the best.
The fusion runs, so it's like the power of teamwork.
Exactly. By combining the strengths of different approaches, they could achieve even higher task success rates and even lower costs.
So it's not just about having a good knowledge graph, it's also about using it effectively.
Right, and they even managed to solve more than twice as many tasks at Hugging Face agents with their best fusion configuration.
Wow, that's incredible.
And they did it with an average cost per solved query that was almost 72% lower than the baseline.
Okay, that's officially amazing. What about the zero-shot models? They're usually pretty cheap to run, right?
True, the zero-shot GPT-4o models did have the lowest average cost per solved task.
But I bet they didn't solve as many tasks.
You're right, they only managed to solve 17 and 29 tasks respectively.
Compared to 71 for the best KGOT configuration.
Exactly, so it's a trade-off. You can save money, but you'll sacrifice performance.
So KGOT strikes a good balance between cost and accuracy.
Exactly. And another interesting finding is that the knowledge graphs never get too big.
Oh, that's good.
Yeah, the maximum number of nodes they observed was only 522.
Which isn't that many considering the complexity of the tasks.
Right, it suggests that the approach can scale to even more challenging problems without running into scalability issues.
Okay, that's reassuring. Now, they also analyze the impact of different design decisions, right?
Yep, they looked at everything from the choice of graph database to the prompt format.
Cool. What were some of the key takeaways?
Well, they found that using graph queries can be really effective. But sometimes the LLM struggles to generate correct queries.
Especially for complex graphs.
Right. On the other hand, using Python gives you more flexibility, and the LLM seems to be better at generating Python code.
Even if that code needs a bit of tweaking sometimes.
Exactly. They also found that direct retrieval works well for certain types of questions, but it's not always the best choice.
Especially for tasks that require more structured reasoning.
Right, and they experimented with different tool sets and prompt formats as well.
And they settled on XML for the prompts, right?
Yeah, they found that XML was more consistent and compatible with their optimizations.
Interesting how those little details can make such a big difference.
They also tested KGOT with different open source language models. They found that it consistently provided performance advantages over just using those models with Hugging Face agents.
So it's not just tied to one specific language model.
Right, and they even found that some open source models like DeepSeek R1 showed really promising zero-shot performance.
Huh. That's exciting.
Yeah, it suggests that there's still a lot of untapped potential in these open source models.
And finally, they did a comparison to a baseline that didn't use any knowledge graphs, right?
Yep, and the results were pretty clear. Using a knowledge graph significantly improved performance.
By how much?
They saw almost a twofold increase in the number of tasks solved.
Wow, that's a big difference.
It is, and it really validates their whole approach.
So the knowledge graph is really the key ingredient here.
Exactly. It's what enables them to achieve these impressive results with smaller, more affordable models.
So what's the big takeaway from all of this?
Well, I think the knowledge graph of thoughts is a really exciting development in AI.
Yeah, I agree.
It has the potential to make AI assistants more powerful, more efficient, and more accessible.
It's like democratizing access to AI.
Exactly. And the results on the GIA benchmark are really compelling.
Yeah, they show that this approach can actually work in practice.
And the modular design means that it can be adapted to different applications and different domains.
So it's not just a one-trick pony.
Right. And I think it raises some really interesting questions about the future of AI.
Like what?
Well, maybe we don't need to keep building bigger and bigger language models.
Right.
Maybe we can achieve similar or even better performance with smaller models that are enhanced with knowledge graphs and tools.
It's like a paradigm shift.
Exactly, and it could have a profound impact on how we develop and deploy AI systems in the future.
So what's the one thing you want our listeners to remember from this deep dive?
I want them to remember that the knowledge graph of thoughts is a powerful new tool for building affordable and highly capable AI assistants.
and that it has the potential to change the way we think about AI.
Exactly. So if you're working on AI assistants or any kind of complex reasoning system, I highly recommend checking out this paper.
Yeah, it's definitely worth a read.
And let us know what you think in the comments.
We'd love to hear your thoughts.
What stands out to you as the most significant implication of this research?
How might you apply these ideas to your own work?
These are the kinds of questions that we should all be asking ourselves as we push the boundaries of AI.
And who knows what amazing breakthroughs are just around the corner.
We can't wait to find out.
Thanks for joining us.
And we'll see you in the next deep dive.